Hey guys, today's really short, which is great because it's Friday. Well, it's the day before the review for the test. So you should open the review at the end of today's notes. Next time, I'm going to probably go over the review just like I do in class, go over each problem. I'll provide a way for you to write that down if you want to use it on the test. And then I will open the test tomorrow and I will have a time for each of you guys to take it. All right. So here's today. We've got lots to cover. We're going to do a review over the distance between points, how to find a line that passes through a point and is parallel or perpendicular to another line. And then we're going to do that area and perimeter stuff that we were doing yesterday. All right, so right here on this particular problem, we're going to find the distance between 2 points. And you know how I like to do this. I like to plot the points. So
I'm going to plot the points. I'm actually going to move that line a little further down.
There we go. All right, and I'm going to plot those points. So I'm going to go over 3 and down 4. And there's going to be my first point. And then my other point is over 12 and up 16. Now, this doesn't need to be perfect. It just needs to be a picture that'll help you visualize what's going on. So there's my line, and I want to know the distance of this line. So I know that from 3 to 12 is really 9 long. And I know that from 16 to -4 is really 20 long. So now I can use Pythagorean theorem, which says 20 squared plus 9 squared equals x squared. See how I labeled this line x? That's why I'm calling it x squared. Now, if I do 20 squared, that'd be 400, and 9 squared is 81, equals x squared. So this is going to be 481 equals x squared. So now if I take the square root of both sides, I'm going to pull out my handy dandy calculator if I can find it, which of course I can't. So we're going to look for it. Here's my calculator. Ah, there we go. Beautiful. Okay, so we're going to take 481 and we're going to take the square root. Okay, and we have 21.93. So the distance or the length of that line is 21.93. It's almost 22, whatever that is, long. So 22 inches, 22 centimeters. I'm not sure what they're measuring, but that's what it is. So we're going to now find a line that passes through this point and is parallel to this line. Now, if you remember, the biggest thing about parallel is that the slopes are the same. So I already know that my slope is -5. And this is my x value. This is my y value. So if we remember back to that equation, we're going to have y minus my y value equals my slope times x minus my x value. So from here, I like to simplify it. And every time I subtract a negative, I need to remember that it's actually adding a positive. So this is really y plus 3. And if I distribute this -5, I get -5x, and -5 times -2 is a positive 10. Now I'm super close to y equals. I've got to subtract this 3 over to this side in order to get that. And this becomes y equals, because this cancels out, the -5x, and then 10 minus 3 is a positive 7. And there's my line that would be parallel to y equals -5x plus 97. And if you actually graphed those two on Desmos, you would see that. All right, so on this next one, we have a line that passes through -2, 1, and it's going to be perpendicular. Now notice this word perpendicular. We are doing perpendicular, which means we have to take our slope and do something different than just copy it down. And we're perpendicular to the line y equals -1/2 x plus 2,000. So now instead of -1/2, in order to make it perpendicular, I have to flip it over, so that'd be 2 over 1, and I have to change from a negative to a positive. So this is really just the number 2, because positive 2 divided by 1 is just 2. All right, so then we have a slope of 2. This is our x value. This is our y value. So again, we're going to do that same thing. So this is going to be y minus my y value equals my slope times x minus my x value. Again, I'm subtracting a negative. That I've got to remember that that's really the same thing as adding a positive. Okay, So now we've got y minus 1, and we're going to take our 2 and we're going to distribute it. So we have y minus 1 equals, and then 2 times x is 2x, and 2 times 2 is just positive 4. Okay, so now I'm so freaking close. All I have to do is get my y alone. So I'm going to go ahead and add 1 to both sides because negative 1 plus 1 is 0, and it kind of just goes away. So that I'm left with y equals, and then I have 2x plus 5. And there's my line that would be perpendicular to negative 1x plus 2,000. And if you graphed these on Desmos, again, you would see that they are actually, in fact, perpendicular to each other. Also, if you have any questions on any of this, please make sure you're leaving comments in the discussion below. If you are not doing that, you are not receiving credit for this discussion. So might as well do it. It's going on 10% of fourth quarter's grade. All right, so for this one, we need to first plot the points. And once we plot the points, we are looking for the perimeter. Notice that this isn't asking for area. That makes our life a little easier. So for A, I'm going to go to negative 7 and then up 3. So here's my x value, and remember that first number is always my x. And then here's my y values, and remember that second number is always my y. So I'm going to go negative 7, 1, 2, 3, 4, 5, 6, 7, up 3, 1, 2, 3. So there's that point. And then for B, I'm going to go right 3. So here's A. I'm going to go right 3, 1, 2, 3, up 3, 1, 2, 3. So here's B. And then C is going to be right 7. So 1, 2, 3, 4, 5, 6, 7, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is C. And then D is going to be left 3. So 1, 2, 3, and then up 8 as well. 2, 3, 4, 5, 6, 7, 8. So here's D. So now if I connect all these dots, here is my parallelogram. Notice that it's not a rectangle. That's super important. What's really nice about this one is it's super easy to count, see how long AB is and how long DC are. So DC is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10 long. And if we could do the same thing to AB, we find that it is also 10 long. Okay, now we need to find how long is AD. And BC will be the same length. So I'm going to use Pythagorean theorem. So this is 1, 2, 3, 4, 5 tall. 1, 2, 3, 4 over. So using Pythagorean theorem, so AD is going to be 5 squared plus 4 squared equals, I'm going to label this x squared. Okay, so this would be 25 plus 16 equals x squared. If I do 25 plus 16 in my calculator, it's 41. So I have 41 equals x squared. Well, x isn't quite by itself yet, so I'm going to take the square root of both sides. And I get x equals, so we're going to take 41, take the square root, 6.40. So that means this is 6.40, and this is 6.40. So if I want to find the perimeter, all I have to do is add all those sides together. So my perimeter is going to be 10 plus 10 plus 6.4 plus 6.4. And I get 32.8. All right, what questions do you guys have there? Please leave them below so that way I can answer them or someone else can. All right, take a look at this one. You're going to do the same thing. So go ahead and pause the video and see if you can try this one on your own. If you can't, then go ahead and watch me go through it. All right. Okay, so here we're going to do A. We're going to do negative 4 up 7. So 1, 2, 3, 4 up 1, 2, 3, 4, 5, 6, 7. This is A. B is going to be negative 1 up 9. This is B. C is negative 1 up 3. This is C. And then D is negative 4, so 2, 3, 4 up 1. Okay, so here's D. So now I can connect the dots. Again, you'll notice that there are 2 lines that are super easy to count how long they are. This one is 1, 2, 3, 4, 5, 6 long, which means that is also 6 long. However, this one right here, we're going to have to actually figure it out using Pythagorean theorem. So again, I'm going to label it x. So the length AB, or you can say DC, Both of those will be the same length. This goes up 2 over 3. So this is 2 squared plus 3 squared equals x squared. So this would be 4 plus 9 equals x squared. So this is 13 equals x squared. If I take the square root of both sides, that would find the length of x. So we pull out our handy dandy calculator and we take 13 and take the square root. So that's 3.61, rounding to the nearest hundredth. So that means that this is 3.61 and this is 3.61. So my perimeter is just going to be 6 plus 6 plus 3.61 plus 3.61. So I'm going to do that in my calculator. 6 plus 6 plus 3.61 plus 3.61. And we get 19.22. Notice that I am rounding to the nearest hundredths because it's asking me to in the problem. If it asked me round to the nearest thousandths, I would need to go 3 decimal places. All right, if you didn't try that one on your own, please go ahead and try this one on your own. Okay, I want you to find, it says the area and the perimeter. I want you to definitely try and find the perimeter. That's going to be the first thing I find in my video, so if you want to go ahead and try that first, go for it. If not, I'm about to do it. So this is 1, 2, 3 long, which makes that also 3 long. Now, if I want to find this length, I'm going to use Pythagorean theorem. So I'm going to call this x. So this goes up 1, 2, 3, 4 over 1. So using Pythagorean theorem, this would be 4 squared plus 1 squared equals x squared. So this would be 16 plus 1 equals x squared. So 17 equals x squared. If we take the square root of both sides, we'll find the length of x. So we're going to take 17, take the square root, and we get 0.12. So I know that this is 4.12, and this is 4.12. So if I want to find the perimeter, I just need to add all those lengths together. So that'd be 3 plus 3 plus 4.12 plus 4.12. So I do 3 plus 3 plus 4.12 plus 4.12. And I get the perimeter is 14.24. Now, area is a tiny bit trickier because to find the height, you need to go straight down so that it's perpendicular to the base. And that's going to be your height. So this is 1, 2, 3, 4 tall. So the area is just the base times the height. Well, the base in this problem is 3. So area equals 3 times 4, which is 12. All right, again, if you have questions, please leave them below. And if you didn't get a chance to try that one on your own, definitely try this next one because this next one's a little easier. It's just finding the distance between 2 points. These are 2 questions that are taken off your PC. We'll go over them again tomorrow when I do the review. All right, so on number 6, it says find the distance between the points -3, 0 and 2, 5. So right here, I like to draw a picture. So I would go -3, 0. So there's my point. And then the other one, it says to go over 2, up 5. So that would be that point right there. So I'm looking for the distance here. So the first thing I'm going to want to know is how long is -3 to 2? This is actually 5 long. And then from 0 to 5, this is also 5 long. So that means that I would do 5 squared plus 5 squared equals x squared, x being the length of that line. So then I would get 25 plus 25 equals x squared, which is 50, equals x squared, and x equals the square root of 50, which ironically is exactly what I would put in there. Which if you don't know how to type that in, this is the same thing as typing SQRT and then in parentheses 50. All right, we've got one more that we're going to do today. All right, so this one's super short. All right, so this says compute the perimeter of the area of a parallelogram determined by the points, these ones right here. So just like I do when I'm doing that, I'm going to sketch a graph and I'm going to do the graph in black because I feel better about the graph in black. So here's my graph. A is over 1, up 3. So here's the point A. Then B is over 9, up 3. So here's my point B. Then C is over 3, up 11. So here's C. And then D is at -5 and 11. So it's right there. Okay, so here's my parallelogram. It looks something like this. Obviously, I'm not perfect. Things are off a little bit, but you'll have to forgive me. Okay, there's my parallelogram. Now, this is going to be the easiest distance for me to find. It's going from -5 to 3. Or you can find it here from going from 1 to 9. If you notice, both of these are 8. Now we have to use Pythagorean theorem to find the length of the side we don't know, which in this case is either DA or CB. It doesn't matter which one you go with, it will be the same. So if I go from 11 down to 3, that's a distance of 11, 10, 9, 8. It's a distance of 8. Interesting. Okay, and then if I go from -5 over to 1, that's a distance of 6. So using Pythagorean theorem so far, this is 8 squared plus 6 squared equals, and I'm going to label it x like I always do, x squared. Okay, so if I do 8 squared plus 6 squared, this is 64 plus 36 equals x squared, which if I add those together, I get 100 equals x squared. What's really nice about this is when I take the square root of both sides, I actually get x equals 10. So I have x equals 10. So this is 10, and this is 10. Now, finding the perimeter is really easy. So the perimeter is just going to be 8 plus 8 plus 10 plus 10, which if I add all those together, that's 36. Now, if I want to find the area, I actually have to take into consideration my height. So my area is going to be my base, which happens to be 8, times my height, which I'm not quite sure of yet, because my height is going to be from here straight down. Which if you look, we already have it. It's 8. So it's going to be 8 times 8. So that means that my area equals 64. Okay. What questions do you guys have here? Please leave them in the comments below. We just finished everything that we're going to be doing with using coordinates to prove geometric theorems. Really, we're just using coordinates to show that we can find area and perimeter. We're not super proving anything. But I hope that you followed this fairly well. Okay,